Hi everyone, welcome back to my channel Criminology and Forensic Science. Let me ask you a question first. Did you ever look carefully at the tips of your fingers? Not just for a second, but really observe those tiny lines that cover every fingertip. They look ordinary, almost meaningless. But what if I told you that these tiny lines have solved hundreds of murders, exposed dangerous criminals, identified disaster victims, prevented fraud worth millions of rupees, and even unlocked your smartphone today? Now, here's something even more interesting. At this very moment, more than 8 billion people are living on Earth. Can you imagine that among all those billions of people, not even a single person has the exact same fingerprint as you? Not your parents, not your siblings, not even an identical twin. Think about that for a moment. Nature has created a personal signature for every human being, and it has done so without repeating it even once. Isn't that absolutely incredible? But have you ever wondered who discovered fingerprints? How did people realize that these tiny ridge patterns could identify criminals? Who transformed a simple thumb impression into one of the strongest pieces of evidence accepted in courts across the world? And here's another surprising question. Did fingerprint science actually begin in Europe, or did it begin in India? Many students preparing for the UGC NET examination get confused about this question because several scientists contributed to fingerprint science. Today we are going to understand the complete story in chronological order so that you will never forget it again. So if you are preparing for UGC NET Forensic Science, Criminology, Police Administration, or any other competitive examination, this lecture is going to be one of the most important classes for you. Keep a notebook beside you because throughout this lecture I will share memory tricks, important examination facts, and previous year concepts that examine how to ask. And before we begin, if you enjoy learning forensic science, don't forget to subscribe. Now let's travel back thousands of years. Today, fingerprints are considered one of the most reliable forms of personal identification. Whenever a crime occurs, one of the first questions investigators ask is, can we recover fingerprints from the crime scene? Why? Because fingerprints rarely lie. A witness can forget. A suspect can change his statements. Documents can be forged. Photographs can be edited, but fingerprints remain faithful to the person who left them. This is exactly why forensic scientists often call fingerprints as nature's signature. But reaching this stage took thousands of years. The science we use today was built step by step by curious people who asked simple questions. Why are these ridge patterns different? Do they ever change? Can they identify people? And every answer brought humanity one step closer to modern forensic science. So let us begin our journey from earliest civilizations. Now imagine yourselves living nearly 4,000 years ago. There are no computers, no police stations, no passports, no Aadhaar cards, no signatures in the modern sense. Business transactions were recorded on wet clay tablets. Now think like a merchant. Suppose you're selling land or grain. How will you prove that the agreement actually belongs to you? The Babylonians found a simple solution. They pressed their fingertips into wet clay before it dried. That tiny impression became part of the official record. At that time, they had absolutely no idea about forensic science. They didn't know anything about individuality or permanence. They simply observed something practical. Each person's finger left a different impression. Without even realizing it, they had made one of the earliest uses of fingerprints in human civilization. Now, here's an interesting point for UGC NET students. The Babylonians used fingerprints, but they did not study fingerprints scientifically. This distinction is extremely important. Examiners sometimes ask whether the Babylonians discovered fingerprint individually. The answer is no. They only used fingerprint impression for authentication. The scientific study came much later. Remember this difference carefully. Now let us move several centuries ahead. This time we arrive in ancient China. Chinese civilization was highly advanced in administration, trade, and governance. Merchants had a problem similar to Babylonians. How could agreements be authenticated? The Chinese began placing thumb impressions on official documents, loans, contracts, and business records. Imagine visiting a government office over 2000 years ago. Instead of signing your name with a pen, you simply pressed your thumb onto the document. That thumb impression became your identity. Even potters unknowingly left fingerprints on their pottery while shaping wet clay. Again, they did not understand fingerprint science, but they trusted fingerprints enough to use them as proof of identity. Think about how remarkable that is. Thousands of years before computers, civilizations already understood that our hands carry something unique. Now comes a part that every Indian forensic science student should know with pride. Long before fingerprint science became famous across Europe, thumb impressions were already being used in India. Many people during ancient and medieval periods could not write their names. Instead of signatures, they used thumb impressions on land records, legal documents, agreements, and official papers. These impressions were accepted as proof of identity. At that time, nobody imagined that one day India would become the birthplace of world's most influential fingerprint classification system. Yes, modern fingerprint science owes an enormous debt to India. And as this lecture progresses, you will understand exactly why. So remember this point, India was not just a user of fingerprints. India later became one of the greatest contributors to fingerprint science. Now our story enters the scientific era. Until now, fingerprints were only being used. Nobody had actually studied them carefully. Then came an Italian physician named Marcello. Imagine living in the 17th century. Microscopes were still relatively new. Most scientists were fascinated by understanding the human body. Marcello was one of them. In 1686, he carefully examined the skin of fingers under a microscope. For the first time, someone studied those tiny ridges scientifically. He noticed that these ridges formed beautiful patterns, some curved, some looped, some spiraled, others formed wave-like structures. Although Marcello never suggested using fingerprints to identify criminals, his observation became the foundation of fingerprint anatomy. Because of his remarkable work, one layer of skin is still called the Malpighian layer. This is why many forensic books call him the father of fingerprint anatomy. Now here is a quick memory trick. Anatomy equals to Marcello. Whenever you hear father of fingerprint anatomy, your mind should immediately say Marcello Malpighi. Simple, never confuse him with Francis Galton. Galton came much later. Now let me ask you something. Suppose you looked at hundreds of fingerprints. Would you automatically believe that every fingerprint is different? Not necessarily. Someone had to prove this idea. That person was the German anatomist Johann Christoph Andreas Mayer. In 1788, Mayer made a revolutionary statement. He said that although fingerprints may look similar, no two individuals have exactly the same arrangement of fingerprint ridges. Think about how extraordinary this statement was. There were no computers, no databases, no AFIS, no digital scanners, only careful observation. Yet Mayer confidently recognized fingerprint individuality. This became one of the greatest principles of forensic science. Today, whenever a forensic expert compares fingerprints in a laboratory, they are relying on the same principle that Mayer recognized more than 2 centuries ago. So remember another important examination point. Mayer did not invent fingerprint classification. He did not solve criminal cases. His greatest contribution was recognizing the uniqueness of fingerprints. Now imagine something. Suppose a police department collects thousands of fingerprints. How will officers search through them? Without organization, fingerprint records would become a huge pile of confusing papers. Someone had to create order. That person was Jan Evangelista. In 1823, this Czech scientist became first person to classify fingerprints scientifically. He divided fingerprint patterns into 9 different groups. Although his system was never widely adopted by police departments, it introduced one very important idea. Fingerprints could be classified. Think about how powerful this idea was. Once fingerprints can be classified, they can also be stored. If they can be stored, they can later be searched. And if they can be searched, criminals can be identified. One simple scientific idea eventually changed criminal investigation forever. Many students overlook Jan because his classification system is no longer used today. But remember, without Jan's work, later scientists like Galton and Henry might never have developed their own systems. Science always builds upon previous discoveries. Now comes one of my favorite stories in the entire history of forensic science, and interestingly, it happened in India. Imagine you are a British officer working in Bengal in the year 1858. Your name is William James Herschel. Every day people sign government contracts, but there is one major problem. Some people later deny that they signed those contracts. Others try to cheat the government. Herschel wanted a solution. One day, while making a contract with a local contractor named Rajadhar Konai, he asked him to place the palm of his hand on the document. At first, Herschel simply wanted to frighten him into honoring the agreement. He believed that seeing one's own handprint on a contract would discourage fraud. But something unexpected happened. Years later, Herschel compared old handprints with new ones. To his surprise, they were exactly the same. Age had changed the person, but it had not changed the fingerprints. Can you imagine his excitement? This simple observation completely transformed his thinking. He realized that fingerprints could become permanent personal identifiers. From that moment onward, Herschel began using fingerprints for pension payment, prisoner identification, and official government records. Without knowing it, he had started one of the greatest revolutions in forensic science. This is why William James Herschel is remembered as the first person to use fingerprints practically for identification. Notice the difference once again. Marcelo studied fingerprints, Mayer recognized uniqueness, Jan classified them, but Herschel actually used them in real life. This difference is also important. So far in our journey, we have traveled through thousands of years of history. We saw how Babylonians unknowingly used fingerprints on clay tablets, how the Chinese trusted thumb impressions as signatures, how India quietly laid the foundation for one of the greatest revolutions in forensic science, and how brilliant minds like Marcelo, Johann Mayer, and Jane Evangelista and William James Herschel each added one important piece to the puzzle. But if you think the story ends here, think again. In fact, we have only reached the beginning of the real revolution. Until now, fingerprints were mainly being used for identification and official records. No one had fully demonstrated how they could become powerful weapons against crime. The next few scientists would completely transform forensic science forever. One of them would suggest using fingerprints to catch criminals, another would scientifically prove that fingerprints are unique and permanent, and another would solve the world's first murder using fingerprint evidence. So let us continue this incredible journey. So now imagine you are a doctor working in Japan in the late 19th century. Every day you treat patients, study diseases and observe people carefully. One day while examining ancient clay pottery, you notice something unusual. The pottery contains tiny impressions left by the fingers of the potters who made them centuries ago. Most people would simply admire the pottery and move on, but not Henry Faulds. He asked himself a simple question. If these fingerprints have survived for centuries on clay, could fresh fingerprints left at a crime scene help identify a criminal? Sometimes the greatest discoveries begin with the simplest questions. Henry Ford was not a police officer, he was not a detective, he was a physician. Yet his curiosity changed forensic science forever. In 1880, Faulds published an article in the famous scientific journal Nature. In his article, he suggested something that sounded revolutionary for that time. He proposed that fingerprints found at crime scenes could be collected, compared, and used to identify criminals. Think about how extraordinary this idea was. Today, every crime investigation begins by searching for fingerprints. But back in 1880, this idea was completely new. Faulds even suggested that powders could be used to develop invisible fingerprints left on surfaces. Doesn't that sound similar? Today, forensic experts use fingerprints powders, magnetic powders, fuming, ninhydrin, and many other techniques to develop latent fingerprints. The foundation of this idea can be traced back to Henry Faulds. Can you imagine how far ahead of his time he was? Henry Faulds once helped solve a case involving fingerprints. A bottle had been handled by several people. Instead of accepting false accusation, Faulds compared the fingerprints and demonstrated that they belonged to someone else. Although this was not a famous murder case, it convinced him that fingerprints could reveal the truth when human memory failed. This is a lesson that every forensic scientist should remember. People may lie, people may forget, but physical evidence does not. That is the beauty of forensic science. Whenever you hear the name Henry Faulds, immediately think of these three words: doctor, nature, criminal identification. Doctor because he was a physician, nature because he published his research in the journal Nature, criminal identification because he was the first to clearly suggest using fingerprints to identify offenders. If you remember three words, you will never confuse Faulds with Herschel or Galton. Now let me ask you another question. Suppose someone claims fingerprints are unique. How would you prove it? Would personal opinion be enough? Of course not. Science requires evidence. It requires observation, research, mathematics, and logical reasoning. This is exactly where Sir Francis Galton entered the story. If William Herschel introduced fingerprints into practical use, Francis Galton transformed them into a scientific discipline. This is why he is known throughout the world as the father of fingerprint science. Francis Galton was a British scientist with an extraordinary curiosity. He studied anthropology, statistics, heredity, psychology, and human variation. Unlike many scientists who focused only on one field, Galton believed that everything in nature could be measured and understood through careful observation. When he began studying fingerprints, he did not simply admire the patterns. He wanted answers. How unique are they? Do they ever change? Can they be classified? Can they be reliably identify every human being? These questions eventually changed forensic science forever. Galton examined thousands of fingerprints from different individuals. Imagine spending years carefully observing countless fingerprints without computers, without digital scanners, and without artificial intelligence. Every comparison had to be made manually. Slowly, a remarkable truth began to emerge. No matter how many fingerprints he examined, he never found two that were exactly alike. This convinced him that the fingerprint individuality was scientifically valid, but Galton did not stop there. He also studied fingerprints collected from the same people over many years. He discovered that although people grow older, fingerprints do not change. Children become adults, adults become elderly, hair turns grey, faces develop wrinkles, but fingerprints remain exactly the same. Can you imagine how astonishing this discovery was? Nature had created an identification system that remained permanent throughout life. In 1892, Francis Galton published his famous book Fingerprints. This book became one of the most influential publications in forensic science. For the first time, fingerprint science was supported by detailed research instead of just simple observation. Galton explained that fingerprints possess two remarkable properties. The first was individuality. No two fingerprints are identical. The second was permanence. Fingerprints remain unchanged throughout life unless the skin is severely damaged. Even today, these two principles remain the foundation of fingerprint identification, but every fingerprint expert in every laboratory across the world relies on these same principles. Think about that. Research conducted more than 100 years ago continues to guide modern forensic investigation. That is the power of true scientific discovery. Now let us explore another brilliant contribution. Imagine looking at two loop patterns. At first glance, they appear almost identical. How can an expert determine whether they belong to the same person? Galton realized that the answer lies in the tiny details. Instead of comparing the overall pattern alone, investigators should compare the small, rich characteristic. Today we call this minutiae. These include ridgings, bifurcations, islands, dots, bridges, enclosures, spurs, and many other rich characteristics. You may have noticed in crime investigation shows that fingerprint experts zoom in on tiny rich details. That method began with Galton's research. He understood that fingerprints are identified not merely by loops or whorls, but by unique arrangement of these microscopic rich characteristics. This idea revolutionized fingerprint comparison. Pause for a moment and think about this. Every day you touch books, mobile phones, doors, tables, pens, water bottles, and countless other objects. Every touch leaves tiny rich details behind. Most of the time you never notice, yet those invisible impressions carry your identity. It is almost as if every object you touch silently remembers you. Isn't that an amazing thought? This is why criminals often underestimate fingerprints. They may wear disguises, they may change clothes, they may destroy documents. But if they touch an object without protection, nature quietly records their presence. That is why fingerprints are often called silent witnesses. Many students ask these questions during UGC NET preparation. The answer is simple. Galton did not merely observe fingerprints, he transformed them into a scientific system. He proved individuality, he proved permanence, he introduced minutiae-based comparison, he classified fingerprint patterns, he published scientific evidence accepted worldwide. These achievements collectively earned him the title that is Father of Fingerprint Science. Remember this title carefully because it is one of the most frequently asked questions in competitive examination. Now we come to one of the most dramatic moments in forensic history. Imagine being a police officer investigating the murder of two innocent children. There are no CCTV cameras, no DNA profiling, no mobile phone records, no digital evidence. How would you identify the killer? This is exactly what happened in Argentina in 1892. A woman named Francisca Rojas claimed that an unknown man had entered her house and brutally murdered her two children. Naturally, the police believed her. They arrested a suspect and questioned him extensively. But something was wrong. There was no convincing evidence against him. The investigation reached a dead end. Then a police official named Juan carefully examined crime scene. He noticed a blood-stained fingerprint left on a door. Instead of ignoring it, he compared it with the fingerprints of Francisca Rojas herself. To everyone's surprise, the bloody fingerprint matched her own finger. Faced with undeniable scientific evidence, she confessed to killing her children. Can you imagine the shock this created? For the first time in history, a murderer was identified through fingerprint evidence. This was not theory, this was not laboratory research, this was a real criminal investigation, and it proved beyond doubt that fingerprints could solve serious crime. The Francisca Rojas case became one of the greatest turning points in forensic science. Police departments around the world suddenly realized something extraordinary. Fingerprints were not merely interesting in scientific patterns, they were reliable criminal evidence. After this case, many countries began taking fingerprint identification very seriously. The confidence of police investigators increased dramatically. Courts gradually accepted fingerprint evidence. Fingerprint bureaus began to emerge. Forensic science had entered a completely new era. Whenever you hear Juan, immediately remember one sentence: first murder solved using fingerprint evidence. Whenever you hear Francis Galton, remember father of fingerprint science. Whenever you hear Henry Faulds, remember first suggested fingerprints for criminal investigation. And whenever you hear William Herschel, remember first practical use of fingerprints in India. If you can remember these four lines, you have already mastered one of the most important areas of fingerprint history for the UGC NET examination. At this stage, fingerprint science had finally proved its worth. Scientists had demonstrated that fingerprints were unique, they were permanent, they could identify criminals, they could solve murder cases, but one enormous challenge still remained. How could police department organize millions of fingerprint records without getting lost in endless files? The answer to that question would once again come from India. At this point, fingerprint science had already proven one thing beyond doubt, that is, fingerprints work. But there was still one massive problem. Imagine you are the head of a police department. Your office contains fingerprint records of 50,000 criminals. Every week, hundreds of new fingerprints arrive. How will you search for a single fingerprint among thousands? Would you compare every fingerprint one by one? Imagine how many weeks or even months would that take. Clearly, a better system was needed. And believe it or not, the solution to this enormous problem was developed right here in India. Let us now meet another remarkable personality in forensic history, Sir Edward Richard Henry. Henry was a British police officer who served as Inspector General of Police in Bengal during British India. Unlike Galton, who focused on scientific research, Henry faced a practical administrative problem. His police department was collecting more and more fingerprint records every year. The records were increasing rapidly. Without a proper filing system, fingerprint identification would soon become impossible. Henry realized that fingerprint science needed more than scientific proof, it needed organization. After all, even the best evidence is useless if investigators cannot find it when they need it. This challenge inspired one of the greatest innovations in forensic history. Now, before we continue, I want to tell you something that many textbooks mention only briefly. Behind every great scientific achievement, there are often brilliant people whose contributions remain hidden. The same happened in fingerprint history. While Edward Henry is rightly remembered for the Henry classification system, two extraordinary Indian fingerprint experts played a crucial role in developing this system. Their names were Azizul Haque and Hem Chandra Bose. As students of forensic science, it is important that we recognize their contributions. History becomes richer when we remember everyone who helped build it. Azizul worked in the Bengal Police Fingerprint Bureau. His exceptional analytical skills helped transform fingerprint classification into a practical system. One of the biggest challenges was assigning numerical values to fingerprint patterns so that records could be searched quickly. Azizul carefully studied fingerprints patterns and developed a mathematical method for arranging and indexing fingerprint records. His work significantly reduced the time required to search thousands of fingerprint cards. Imagine searching for one book in a library without shelves or catalogs. Almost impossible. Now imagine the same library arranged alphabetically with proper numbering. Finding a book suddenly becomes simple. This is exactly what Azizul helped achieve for fingerprint records. Without such organization, fingerprint science could never have expanded worldwide. Alongside Azizul worked another brilliant Indian expert, Hem Chandra Bose. Bose refined many practical aspects of fingerprint filing. He simplified procedures, improved record management, and helped make fingerprint classification easier for police officers. His contributions ensured that classification system was not merely scientifically correct but also practical for everyday police work. Together, Azizul and Bose transformed Henry's vision into a working system that police departments could actually use. Today, historians increasingly acknowledge that the Henry classification system was truly a collaborative achievement involving Edward Henry, Azizul, and Hem Chandra Bose. As future forensic scientists, it is important to appreciate the contribution of these Indian pioneers. Finally, in 1897, the famous Henry classification system was introduced. This system became one of the greatest milestones in forensic science. Instead of storing fingerprints randomly, they were classified according to fingerprint patterns, particularly whorls, and assigned numerical values. These values formed a classification formula that allowed investigators to locate fingerprint records quickly. Think about this for a moment. Before this system, searching fingerprint records could take days or even weeks. After the Henry classification system, investigators could narrow the search dramatically. What once seemed impossible became practical. This transformed fingerprint identification from a scientific curiosity into an efficient police tool. Very soon, police departments around the world began adopting the Henry system. For many decades, it became the standard method of fingerprint classification in countries including India, the United Kingdom, United States, and many parts of the Commonwealth. That is why the Henry classification system remains one of the most important topics in forensic science and UGC NET examinations. Now comes another historic achievement. In 1897, something extraordinary happened in India. The world's first fingerprint bureau was established in Kolkata, then known as Calcutta. Pause for a moment and appreciate the significance of this achievement. The very first official fingerprint bureau in the entire world was established in Calcutta. This bureau became responsible for collecting, preserving, classifying, and comparing fingerprints for criminal investigation. It soon demonstrated that fingerprint identification was faster, more reliable, and more accurate than earlier identification methods. For every Indian forensic science student, this is a moment of pride. India did not merely contribute to fingerprint science, India became one of its global leaders. Before fingerprints became popular, many police departments relied on another identification method called anthropometry, developed by Alphonse Bertillon. Anthropometry involved measuring different parts of the human body, including head, length, arm length, foot size, ear dimensions, and body height. Initially, this method appeared scientific. However, it had several serious problems. Body measurements could change with age, illness, or measurement errors. Different officers sometimes recorded slightly different values. Most importantly, two individuals could have very similar body measurements. Fingerprints solved all these problems. They remained permanent throughout life. They were unique to every individual. They required much less space for storage. They were easier to compare. Gradually, fingerprint identification replaced anthropometry in police departments across the world. This marked one of the greatest transformations in the history of criminal investigation. As the 20th century progressed, fingerprint science continued to evolve. Police organizations established fingerprint bureaus, courts accepted fingerprint evidence, fingerprint experts received specialized training, crime scene investigators learned methods for developing latent fingerprints using powders, chemicals, and photography. Fingerprints became indispensable in criminal investigations. Today, fingerprint identification is used not only for solving crimes but also for passport verification, immigration, banking, employment screening, biometric attendance system, mobile phone security, election, disaster victim identification, and missing person investigation. Every time you unlock your smartphone using your fingerprint, you are using the same scientific principle developed by these pioneering scientists more than a century ago. Isn't it fascinating that history lives in the palm of your hand? Now let us enter the 21st century. Imagine comparing one fingerprint against 10 million fingerprint records manually. It would take months or even years. This challenge led to another remarkable innovation, AFIS, or the Automated Fingerprint Identification System. AFIS uses computers to scan fingerprints, extract minutiae, compare rich characteristics, and search massive fingerprint databases within minutes. What once required weeks of manual comparison can now be completed almost instantly. However, there is an important point for UGC NET students. How many people believe AFIS itself identifies criminals? That is not completely correct. AFIS generates a list of possible matches. The final decision is still made by trained fingerprint experts through detailed comparison. Technology assists forensic scientists, but it does not replace them. Human expertise remains essential. Let us pause for a moment, think about this incredible journey. It began with simple thumb impressions on clay tablets. It passed through curious physicians studying skin ridges under microscopes. It continued with scientists proving uniqueness and permanence. Police officers solved murder cases. Indian experts organized fingerprint records. Fingerprint bureaus were established. Today, powerful computers search millions of fingerprints in seconds. What an extraordinary journey. One small ridge on your fingertip carries thousands of years of scientific history, and perhaps the most beautiful lesson is this: great discoveries do not happen because people have powerful machines. They happen because someone asks an important question. Marcelo asked what these ridges looked like. Mayer asked whether they were unique. Jan asked whether they could be classified. Herschel asked whether they changed. Faulds asked whether they could catch criminals. Galton asked whether science could prove their uniqueness. Henry asked how millions of fingerprints could be organized. Each question moved humanity one step forward, and that is exactly how science grows. Now let us revise everything one final time. Whenever you hear Marcelo Malfigi, remember father of fingerprint anatomy. Whenever you hear Johann Mayer, remember first scientist to recognize fingerprint individuality. Whenever you hear Jan Evangelista, remember first scientific fingerprint classification. Whenever you hear William James Herschel, remember first practical use of fingerprints in India. And whenever you hear Henry Faulds, remember that he is the first scientist to suggest fingerprints for criminal investigation. Whenever you hear Sir Francis Galton, immediately answer father of fingerprint science. Whenever you hear Joanne Wostick, remember solved the world's first murder case using fingerprint evidence. Whenever you hear Sir Edward Henry, remember Henry classification system. Whenever you hear Azizul and Hemchandra Bose, remember Indian pioneers who played a major role in developing and refining the Henry classification system. Whenever someone asks where was the world's first fingerprint bureau established, your answer should immediately be Calcutta, India in 1897. And finally, whenever someone asks what is AFIS, your answer should be Automated Fingerprint Identification System. That is a computerized system that compares fingerprints rapidly using digital databases, while the final identification is confirmed only by trained fingerprint experts. If you can remember these points, you have mastered one of the most important topics in fingerprint history for the UGC NET examination. Before we end this lecture, I want you to think about something. Every single day, without even realizing it, you leave hundreds of fingerprints behind on your notebook, on your laptop, on your mobile phone, on your coffee cup, on the door handle of your home. Most of those fingerprints disappear unnoticed. But imagine if every one of those tiny rich patterns could tell a story about where you were, where you touched, whom you helped, or perhaps how justice was finally delivered because of one invisible fingerprint. That is the beauty of forensic science. It teaches us that the smallest piece of evidence can reveal the biggest truth. A single fingerprint may be invisible to our eyes, but in the hands of a trained forensic scientist, it can speak louder than 100 witnesses. It can expose lies, it can protect the innocent, it can identify the unknown, it can reunite families after disasters, and sometimes it can become the silent voice that helps justice prevail. Never underestimate the power of small details. History has shown us again and again that some of the world's greatest discoveries began with someone noticing something that everyone else ignored. As future forensic scientists, criminologists, researchers, investigators, or UGC NET aspirants, cultivate that habit of observation. Ask questions. Stay curious. Read beyond your textbooks. Because every great scientist we discuss today, from Marcelo to Galton, from Herschel to Henry, changed the world not because they had extraordinary technology, but because they had extraordinary curiosity. And to every student preparing for the UGC NET examination, I want to leave you with this message. Success in forensic science is not about memorizing hundreds of facts overnight. It is about understanding the journey behind those facts. When you understand the story, dates become meaningful, names become unforgettable, concepts become connected, That is exactly how toppers prepare. So don't just study just to clear an examination. Study because one day you may become the forensic expert whose opinion helps solve a murder, identify an unknown victim, protect an innocent person, or bring justice to a grieving family. That responsibility begins with learning the fundamentals well. And today you have completed one of those fundamentals. Be proud of yourselves, keep learning, keep growing, and never stop asking questions. If you found today's lecture helpful, please support the channel by liking the video, sharing it with your friends, and by subscribing if you haven't already. Tell me in the comments which scientist's contribution impressed you the most and why. Was it Marcello's curiosity, Herschel's practical thinking, Faulds' revolutionary idea, Galton's scientific proof, or the incredible contributions of Edward Henry, Azizul, and Hem Chandra Bose that transformed fingerprint science forever? I would love to read your thoughts. In our next lecture, we will continue our journey into another exciting topic of forensic science, explained in the same simple style that makes learning enjoyable and easy to remember. Until then, take care of yourselves, keep believing in your dreams, keep preparing with your confidence, and always remember every fingerprint is unique, just like every learner's journey. Your path may be different from everyone else's, but with your patience, consistency, and curiosity, your efforts will leave a mark that no one else can ever replace. Thank you so much for watching. I'll see you in the next lecture. Happy learning.